Good. My name is Ronnie Timmermans. Welcome everybody to the webinar of today. A few practical things. The webinar will be recorded. And if you have questions and remarks, you can post them in the questions and answers section. So we'll treat them at the end of the webinar or maybe at a later opportunity if the questions need more depth of responses. As I introduce myself, Ronnie from Xenit. Xenit has been a long-standing Alfresco partner, and we have been on a journey and a route to almost always better operational excellence. And it is in that frame that the collaboration with Oxford University Press fits very well. I think we have been in the last year on a dauntless journey towards operational excellence, hosting Alfresco on AWS and doing that with all of the state-of-the-art means and technologies that we have available. So we're very happy because this is also a major leap for Xenit in terms of professional managed services with Alfresco. Further on, it is my pleasure and my honor to introduce the most distinguished speakers of today. We're very happy to have two guests from Oxford University Press, Miles Kempson, the Service Delivery Manager of Oxford University Press for all processes around Alfresco and creating digital assets that serve the business of OUP. Miles will, of course, explain himself what that represents. And after Miles, we will have Mark Bale. Mark is an application architect, and I would say one of the inventors and visionaries of the architecture of the system of Dauntless, a source of inspiration for ourselves. He will humbly deny, but we think so. And after Mark, there will be two speakers from Xenit. First of all, Thijs Lemmens. Thijs is our Chief Product Officer. He has played a role in coordinating, in researching everything that was necessary to put Dauntless into practice using Kubernetes on AWS, of course. And after, I think Thijs will highlight in particular observability in the platform. And the last speaker, last but not least, of course, is Joost Kupere, one of our senior software engineers and the guy that did a lot of work to make all of this happen and make a reality of the platform with everything that goes with it. And Joost will zoom in a bit more on the aspects of continuous delivery, continuous integration. So having said that, I would like to pass on the word to Miles that says something about Oxford University Press.
Okay, good afternoon, everyone. So who are OUP? We are the Oxford University's publishing division, and we publish in many countries for all audiences in more than 40 languages. These include educational institutes for preschool and secondary level, from students to academics, to readers to researchers, and from individuals to institutions. Our divisions cover education, English language teaching, higher education, academic, which of course does include the Oxford English Dictionary, and we've been doing this for 400 years. Going on now to our digital transformation, we have been using Alfresco as a digital asset management system since 2012, and DAM application currently contains millions of assets and a significant value of IP, and is still very much at the heart of our work in progress for our education and ELT divisions. We wanted to bring automated content flow process to our academic books and journals, and so our end-to-end publishing application, Atlas, was born using Alfresco content and Alfresco process services, supported by our own microservices that support the transformations and content standardization services. So when we started this 4 years ago, it started off small, and we were able to work within the performance specifications originally set out for us. But we became a victim of our own success as usage has grown rapidly and has exceeded the application's capabilities. So this has come about through the drive for delivery of digital products increasing over the last few years, And we are now charged with delivering 80% of our academic digital content using this system. We have delivered thousands of books containing millions of assets through Atlas. And when you consider some of these aren't just single PDFs, they are huge complex books like the Oxford Medical Dictionary, combined with millions of journals, it's really clear that a whole new approach was needed, especially as our other divisions are looking at this system and are queuing up to use it as well. So I had a chat with Mark over a cup of coffee, our cross-functional application architect, and Zenit, our support provider, and we came up with a solution. And this is the point where I now hand you over to Mark, who's really the brains here behind its development.
Thank you, Miles. As Ronnie said, I will deny everything. Miles rightly said, we've been on a heck of a journey with Alfresco in Oxford University Press, and presently it's currently providing 3 different roles within our business workflow. It's operating as a work in progress store, it's operating as a reusable asset store, and it's operating as a version of record store. Now, the first 2 operate as a single instance, and the version of record store is a separate one. Between those 2, they deal with all content creation flows, they deal with our validation, our content transformation, and the content delivery processes. So long, detailed flows going through the whole life cycle. And we've been on quite a journey with this. As Miles said, back in 2012, we had our on-premise instance of this. And that was our very first instance of Alfresco running all of these services. That has run for just under 10 years. And then in 2020, we started with our first AWS hosted instance, where we took a off-the-shelf design that we were recommended. We started building out Alfresco into AWS. We started learning from that, and we built out the version of record store. Alongside of that, we went through a process of upgrading our DAM service that was previously on-prem, and we migrated that to the cloud. During both of those, we've actually been through quite a few journeys, learning things that work, things that don't work, things that we should have avoided in the first place. And as a result, we then came to Zenit and Ronnie and said, we need to take these services apart and redo them and actually migrate to a cloud native design and build from the lessons that we've learned during this process. There've been multiple elements. As Miles says, we've had significant growth, and our version of record store is already at over 150% of our anticipated growth. So significantly more than we expected. We already have several years in AWS, so we've actually gotten used to working with their environments, with some of the tools available, but we've equally found some of the things that limited us in the way that we were developing and deploying. During all of this, the team have actually grown significantly more skilled in the way that we work, the way that we develop, the way that we understand Alfresco. There are still things we need to learn. As with many systems, Alfresco is still constantly growing. And as a team, we still need to actually pick up on the changes. We need to grow. We also need to support the changes in the way our business operates, because off the shelf, we change. Nobody wants a business that doesn't change, so we have to reflect those changes in our capabilities. Additionally, we've also been working more with Zenit, who have guided us through a great many things and a great many improvements over time. Some of the things that we found that have been more bad, we've got slightly rigid environments. The off-the-shelf design is very monotonic in its development. It's a single AWS AMI. It deploys as single servers. It's not fantastically designed by way of separation. We have share services hosted on the same server as Alfresco's core service. We have Solar services operating on the same core as Alfresco as well. And all of these are coming from the same core design that gets deployed. So as a result, we end up being very limited in the way that we can balance the services. If we have to add, for example, more storage space for solar, we have to add the same amount of storage space across every server in the cluster. And that can become quite expensive and very slow. We've also found that we have issues with the way that some of the elements deploy, some of the processes in the way that we have to update solar. For example, it can result in a service that takes a long time for it to restart if there's ever an issue, or if we ever actually need to do a deployment. So we're not operating in a good cloud manner. These processes hinder us and have held us back in getting the best out of the service. And then we get on to the more ugly elements of it. The stack is fragile. As I said, if we have to update solar, it takes a significant amount of time for a server to restart. That's not the best. And if solar fails, we have to change our indexes, we have to rebuild those. We're looking at multiple days in which it takes to redo those. And that in a busy environment is not an acceptable solution. So that is one of the key things that we've also brought along. We've also found that over time, due to the way that the environment has expanded, grown, and developed, some of the elements have drifted. Our production environment is not quite the same configuration as our UAT, which, as many people would understand, is not the best of places to be. Our UAT environment doesn't quite match our test environment, and our development environment, well, we all know that developers have to try things and learn and so forth. So we've had to wipe that, we've had to restart it. And as a result, it's grown and changed and moved away from what the other environments are. And so same problem, different problems. But probably the biggest and most the biggest and most concerning element is we have manual deployment processes. When we need to update our deployed jars, our deployed amps, and so forth, we need to manually put them into specific locations. If we need to change configuration, we have to manually update deployment scripts. If we need to update a database or release a new version of Alfresco, these need significant changes in the infrastructure. All of these result in problems in virtually every deployment. Not the most convincing of situations to be in, and not the most useful. So moving on from those, we've decided and set a whole series of goals for how we wanted to be able to actually work into the future. And this is a long list. It's not the most sensible thing to just read out, but there are several key elements here. Things like cloud native design. We wanted to be able to actually build this in such a way it takes advantage of all of the capabilities that AWS will allow us to use. We're moving up to Alfresco version 7, which by nature is a container-based deployment. And previously, where we'd used to have to manage each operating system and each deployment, that would add additional complexity to our environments. So being able to move to a container-based structure allows us much more flexibility in the way that we deploy and the ability to scale better. And the other things that we're really key on are monitoring everything. We already were monitoring. We had our logging going centrally, but it's been piecemeal. It was added over the top of an infrastructure that wasn't well designed for it. So having an infrastructure that is now designed from the start to allow us to monitor everything through its life allows us to understand what the service is doing and why. And by being able to actually see what the service is doing, why it's doing it, how it's doing it, and the impact on the life and the usage, allows us to actually be able to report on it. If you don't know what something's doing, you can't report on what it's doing. If you can't report on what something's doing, you can't then prove that you have made improvements. You can't say we have been more stable over the last 12 months, for example, because we've got no metrics to be able to prove it. And some of our longer term goals, we know that in the future, we are likely as a global company to need to host some of our capabilities closer to our business units distributed around the world and allow them to have better access to the materials they were working on, particularly as we move into areas where asset size grows significantly with new technologies. Along with that, we need to be able to support cleanly and quickly new versions of Alfresco. Presently, we're on older, unsupported versions of Alfresco, and this has been holding us back. We also are looking at reusing the work that we've been doing on this architecture for Alfresco process, which is a key element of some of our deliverables. As we mentioned, we are running all of our deliveries through this. That involves a lot of workflow management, a lot of transformations, a lot of knowledge and flows of data. And so Alfresco process is key for us, and we're going to be looking to actually take it through a similar journey. We're also very much looking to see what the information we gain from that observability will allow us to understand about how we want to grow and change the design and the stack into the future. And with that, I will sum up there. So thank you. And I will hand you on to Tees next.
That's okay to you, Mark. I will take over. Tess will come after me. Okay, we're going to dive into a bit of a technical presentation. Let's enlarge it. I will mainly focus on the CI/CD aspect, as Ronnie mentioned. But before we start that, let's take one step back and go into the shortest description of Kubernetes on the planet. So Kubernetes, why do we do it? First of all, Alfresco moved to a microservice-oriented architecture. And for this, a container-based approach is ideal, since we can we have a lightweight way of packaging, deploying all these applications. And then if you think about containers, you think about container orchestration, and then the industry standard for years now has been Kubernetes. It comes out of the box with a whole lot of useful tools like scaling. It's very easy to just alter one parameter in a YAML or a JSON manifest, and Kubernetes will horizontally scale up extra containers. It will automatically load balance traffic over these new containers, so that it's also fault resistant, and this comes all automatically. So that's very convenient. The biggest strength, in my opinion, is the resilience that Kubernetes offers. It will constantly monitor the desired state as written down in your Kubernetes manifests, and compare that with the actual state of all services running on your cluster. And if it sees that something is lacking or not corresponding to that desired state, it will take action automatically to resolve this by spinning up extra pods or scaling them down. On top of that, they have native support for health checks. So they have different kind of probes to see, is my container actually up? You can configure these as you like to make sure that all the containers that are running, that they are in fact still healthy, that they are ready to serve traffic. And if not, Kubernetes will kill them and start up new ones for you. There is a big community also behind Kubernetes. It's been a standard for years. So there's a lot of documentation, a lot of open source projects that you can use to leverage your own projects. It's also a technology agnostic stack. So, we use it on AWS. So for Oxford, it's not the biggest selling point, but, if they ever say we want to switch to another cloud provider, then Kubernetes won't be the thing that logs them in for sure. Okay, then let's take a look at Alfresco in the new architecture. I told you that it's microservice oriented, and that's what we see here actually. So if we run it in a Kubernetes cluster, it would look something like this. So the beating heart of everything is your ACS, and on top of that we have all additional features to make this work. Like you have your search services to make it so you can connect to your Solr or your Elasticsearch. You have if you want to use a sync service, you will have another service running for that. There is a message queue connecting various parts. You have your transform services, where they also separated it into different microservices. You have a shared file store router to manage all this, and then your transform services itself. This can be an all-in-one, or it can be multiple transform services separately that are then connected by the router. Traffic will then from a user come into an egress. That's just how Kubernetes works. And from there you can specify, okay, from this host with that path, I want people to go to share. This path, people can go to digital workspace. Maybe on a different host you have another service running. So that's generally how it would look. On AWS, that comes down to quite a bit of services. So that's something to be aware of. Of course, we have our Kubernetes cluster. We run this with Amazon EKS. To get traffic towards that cluster, we need a load balancer. So we have a load balancer on top of that. We want to persist data by itself in Kubernetes. Pods can spin up and spin down, but yeah, we want our database to be persisted, of course. For that, we use an RDS. For the content itself, we use S3. Then the Solr indexes are connected to Amazon EBS. That's block storage. And for transformation services, to link those to ACS, we have an Elastic file system. This is then our container stack. Tess will go into that a bit deeper. As you can see, it's quite a bit of pieces, but they come together quite nicely. Then, how do we do it? The first thing that you have to think about is how will we get our application code towards Docker containers? At Xenit, this has been something we've been doing since 2016 in a production environment. We have quite a bit of toolings ourselves to make this easy, like Docker images that can read out environment variables and put them in your Alfresco global properties. We enable JSON logging and other, neat features. Alfresco itself has been pushing for Docker images for quite a few years already, so I think most of you know. But if you're interested in our own images, they're open source, so you can always take a look at those. Now, that's the container images, but for Kubernetes, we need to go a step forward. In Kubernetes, how do you tell a Kubernetes system what we want to run actually? That's via a thing called manifest. So here you see an example of such a YAML file that will actually describe, in this case, a config map that we want to store. You saw how big the schema of Alfresco is. So in the end, this results in a lot of YAML files. And most of these YAML files on different environments, you want the same structure, but a config map will probably be a bit different. And you will connect to a different database endpoint or such things. Probably in production, you want to be scaled up a bit more than you are on your dev environment. So to make this a bit more convenient, we use Helm. It's also an industry standard for used alongside Kubernetes. It's basically a package manager for Kubernetes manifests. Alfresco has one themselves, but they mention that it's not production ready. So we started building our own, which we believe is production ready. We added features like proper resource management. So you can say, okay, what do I expect my Solar image to use? How much CPU and RAM should be reserved for this before it's scheduled on a node? All those things you can configure with us. For our Solars, we provide automatic backups and restorations towards and from S3. Kubernetes will scale up and scale down, but if your Solar image has to start indexing every time it does that, then you're losing a bit the magic of Kubernetes, because it's supposed to spin up. You have a probe that checks if it's ready. If so, it serves traffic, and there you go. But if you have to wait hours and hours, that clashes a bit. So that's why we thought of this solution. We also provided custom health checks to see, so that our Solar image actually is indicated, hey, I'm alive, but maybe it's still restoring a backup. So it's saying, but I'm not ready for traffic. So then Kubernetes is smart enough to see, okay, it's alive, I won't kill it, but it's not ready for traffic. So all traffic that comes in, I will divert to Solar images that are actually live. We also provide included network policies. So your Alfresco runs in a secure environment where all pods can only access the things that they need to access, and then a bunch of other general best practices. Then the CI/CD pipeline. I mentioned already you want your code on Docker image, and you describe to Kubernetes what Docker image they need to use. But okay, there's a lot of steps going on here. How do we get this automated? How do we, make the CI/CD pipeline fast, clear, and where possible automated? So for this, we opted for a GitOps practice. First of all, in Kubernetes, we chose to use infrastructure as a code. We will write down in a GitHub repo how we want our Kubernetes setup to look like. So that Helm chart or all those manifests, we put them in a GitHub repository, so we can leverage the same best practices that we are using already for years and years in the developer space of application repos. We can use pull requests, we can use branching strategies. So all those things that have been working for years and years, we will leverage in an infrastructure setup. How does this look like for us? So we have an application repository. These can be multiple ones, and then an environment repo. So the first step is, of course, we need to make our images. So for this, I think that's not super new for most people. Pull requests are merged. Your CI/CD action, for example, a GitHub action kicks in. Some know it more from Jenkins, and it builds an image. Of course, on top of that, you do all your automated testing, etc. Once this image is pushed to a Docker registry, we want this Docker image to run on our cluster somehow. So how we do that is we first need to connect our environment repo where we describe what we want to run on our cluster towards that Docker registry. We played around a bit with GitHub Actions first. That was working, but then we discovered Renovate. if people know Dependabot, it's Dependabot on steroids. It's really nice tool that can monitor for you your repo. It will discover, recognize this is a Helm chart. It's using these Docker images, and it will for you monitor that those Docker registries. If it sees there is a new version, it will create a pull request for you, and then you can set it up if you wanted to auto merge or people approve it, etc., etc. So good. Now it's automatically in our environment repo already. How do we get it in our cluster? For that, we use a tool called Argo. So Argo CD is actually a tool that's running on our cluster. So on this Kubernetes cluster, we have a pod running with Argo, and Argo will constantly check our environment repo and our Kubernetes resources, and it will compare those to each other. If it sees a difference, it can alert you, it can sync automatically, you can sync manually, etc. So this is building that bridge. Then one last small thing to be aware of if we are working with GitOps, where do we store our sensitive data? We don't want to put our passwords, etc. in our GitHub repo. That's just general best practice. So for that, we use AWS Secret Manager. So all our secrets are stored in there. And in our environment repo, we simply say, what secret? Okay, then let's do a bit of demo. First of all, I'm going to start showing you Argo CD. Remember, this is the link between our cluster and our environment repo. So as you see here, we have what they call in Argo CD an application, Dauntless demo. And Argo has a nice UI where it shows you what is actually running in this application. So that Helm chart that we have of YAML files, it translates it to an easy to process UI where it says like, okay, these config maps are running. We have here some services. We have here a lot of deployments. They result into replica sets, which in turn result into pods, etc. If we want to see a bit more technical information, like how does that YAML file then look like, we can click on it. We see how it looks like. If there is a difference with the live one, we can take a look at it. We can take a look at the logs. If it's a pod, we can shell into it. So it offers a lot of, at the first glance, it gives a lot of visibility already. Then I have here my environment repo. Let me first show you that this ACS pod is currently running on version 1.2.0. And as you see, everything is healthy. Let's expand this a bit. We see nothing is out of sync. Everything is healthy. Argo CD is synced with the cluster. It's nice. Now, what happens if I go to my environment repo? I already pushed a new version of an image earlier. So we will see that Renovate actually discovered this. So you see, Renovate bot was kind enough to open a pull request for me saying, hey, 1.2.0, there's a new version 1.2.1. Let's merge it in actually. So this is how simple it all can be. Once merged, we go and take a look at Argo. We go into refresh the screen. And now the real magic happens. We see, oh, suddenly things are out of sync. The ACS image is out of sync. We can take a look. What's going on here? What's the difference here? And we see that the image is going from 1.2.0 to 1.2.1. This could have been set on an automatic sync, but it is not for demo purposes. So now I can say I want to sync these, and this will display nicely how Kubernetes will handle these things. So we are back synced up. And what do we see now? Our ACS application has spun up a new replica set. Important, keeping up the one that we have, because this one is not ready yet. So traffic is still being served to this healthy pod. Once this pod will be up and running, traffic will be served to that one. This one will be terminated. And now we have a nice CI/CD pipeline like that. I think that concludes it. So we'll hand over to Tess now.
Right, I'll start sharing my screen then. Okay. Is that clear?
Yeah.
All right, so thank you, Joost. Now that we know how Alfresco is running on Kubernetes, it's important to know how will we keep an eye on this Alfresco or other applications, because monitoring is not strictly to Alfresco. And yeah, we have a 3-leg strategy for monitoring. One, we start on the right side with metrics. We do that with a Prometheus stack. In the middle, you have Amazon CloudWatch, and we use that for logs. Can be used for other things as well, but we chose to use it for logs only. And on the left side, we have Amazon X-Ray, and that's a service we use for traces. Now, those are 3 different tools. They all have a UI, but we like to have actually all these logs, traces, and metrics in one UI, and therefore we use Grafana. And we don't like to set up all these things manually, because the monitoring itself, it's not our core business. That's why we chose the managed services from Amazon. So Amazon has a managed Prometheus, the CloudWatch is a product from Amazon itself, X-Ray as well, and they have a managed Grafana. So we don't need to set it up ourselves. We can do that with a few clicks of a button. However, we do need to integrate those tools into our EKS stack. And I'll show you on the next slides how we do that. And we start off with the logs. So on the left side, we see here, this represents our cluster with the worker nodes. So those are the servers that run the actual pods in our Kubernetes cluster. Each of those pods, they will write logs. We made some changes to Alfresco, Share, and Solar so that they write both application logs and access logs to a structured JSON format to standard out. So the worker node will actually take care of storing those logs in files on the worker node's file system. And then the tool we use to integrate with Amazon CloudWatch is called FluentBit. FluentBit will talk to the Kubernetes API to know what logs that need, what pods are actually running, where we need to, from what pods we need to get the logs. And it will mount the file system from the host that contains the logs into a container or pod, and tail those logs and send them to Amazon CloudWatch that serves as a log database. FluentBit has to run on every worker node because it's mounting the file system, and pods can be on all of these nodes. And the way to do that in Kubernetes is to run it as a daemon set. A daemon set will make a pod for every worker node. The next thing is metrics. So for metrics, we use the Prometheus system. Inside the EKS cluster, we run a pod or multiple pods with OpenTelemetry collector. OpenTelemetry collector has a little Prometheus built in, so you could use Prometheus here itself instead. but since we use OpenTelemetry later for the traces, we use it here as well. And the OpenTelemetry collector will also talk to the Kubernetes API and ask for pods that have certain labels. Those are annotations actually that say that they have a Prometheus endpoint to scrape, and then it will scrape those pods and fetch the metrics and send it to Prometheus. What did we do on ACS and Solar side? We implemented a module Alfred Telemetry, which exposes metrics from Alfresco and the JVM on the Prometheus endpoint. And it integrates with what Alfresco has done itself. Then the last leg is the tracing. The traces enable us to look at the request and see where it went. Like if you do a request to Alfresco share, it will probably do, share will do a request to ACS, and ACS might do, if it's a search, a request to Solar to get results and then get some things from the database. With traces allow us to view the whole journey of one request and do timings. Now, how do we collect those traces? Again, we use OpenTelemetry, and OpenTelemetry has an operator that does some magic. So on ACS share and Solar, actually, we didn't need to do anything. We just installed the OpenTelemetry operator on our cluster and attached some specific annotations again to instruct OpenTelemetry operator to instrument these pods. So actually there's a Java agent injected into the pod that will be configured to write traces to OpenTelemetry collector that will forward it to X-Ray. So that's actually a nice solution with not too much impact. Here we did it for Java, but OpenTelemetry operator supports other technologies like Python and .NET as well. So enough on the slides now. Let's start off with a little demo and we'll go to the Grafana interface. So this is Amazon's managed Grafana. And yeah, here are all of these data sources, the Prometheus metrics, the CloudWatch logs, and the X-ray traces come together in one interface. And I built a dashboard for this demo for each one of those. Let's start off with the logs. Okay. Now I open the dashboard of the logs and it needs to do some queries. I'll take the last 3 hours because otherwise I don't have a nice distribution here. I did some requests before this and it shows it better. So I told you already we implemented some access logging in JSON, and that enables us to make actually specific graphs on access logs. Like here is a graph on response times percentiles, where we can see like the 99, 95, and 90% of the requests are below a certain threshold. If I take it here, like it's all the 99 threshold is below 175 milliseconds. So that's quite good. Of course, it's a demo Alfresco. And then we have a pie chart here to say, you know, almost half of the requests are going to ACS. A bit less is going to share, and then there are some requests to Solar as well. So we immediately have a bit of an idea of what the distribution is there. Another graph we can show here is the request rates per response code. So most of the requests are, make it a bit bigger, our 200 requests are going well, but if you want to zoom into some things that don't go so well, like 500, we can see here around 20 before 4, I made some requests that failed and that show up here in the logs, and that enables us to go and look a bit deeper into the problem. There are some other graphs here, and the access logs can also be viewed in a table. So that's all about access logs. What we have as well, of course, is application logs. They are here, yes. So in this case, it's mostly Kubernetes probing Alfresco to ask if it's alive, and that writes some info logs in this case. That's what we see. If we open a log up, we can actually see the JSON format where this is coming from. So this is the structured format we implemented, and those fields are extracted, and we can actually format how we want the lines here. From here, we can also go into a more explorative view, the Explorer view of Grafana. And we can see the same things. And you can see here how the query of that dashboard was made and how the fields are concatenated to reach these logs. Now, this is useful because now you see we have a lot of info messages, and it's not easy to see that there are actually some warnings or errors in there. So what we can do here is add an extra filter to the query, like severity is not info. And then we can rerun the query and see that there are some warnings on, there were some retries on ActiveMQ. There was an exception, and we can look into more detail here. There are also buttons to switch to the Amazon CloudWatch console. So I'll leave it here for the logs, and let's go to the metrics. I'll do that a bit quicker. Let's take the last 30 minutes. Last 50. So with Alfred telemetry, we have metrics for Alfresco based on micrometer. Micrometer, of course, comes with a bunch of JVM specific metrics. So we can look at the Java heap sizes and usage to spot possible issues, the number of threads. One of the specific things here is the DB connection pool. We can follow that up and see if it's getting close to maximum. Now it's rarely used, so we don't see a lot of connections. If you have a lot of slow queries, this will go up pretty quickly. So metrics can be used in a dashboard as well. And then the last thing I want to show is we actually have the traces with Amazon X-Ray and how we can use that. I'll take the last 3 hours. And yeah, now I see all the traces, but there is a query language for traces as well. And you have some auto fill. So I want all the traces that take longer than, let's say, 2 seconds. I don't have to add the seconds. And let's URL. I want the ones from share. Copy paste the share URL here. Now I'll run the query again. Take a while. All right. So I see here a bunch of requests that took longer than 2 seconds. Let's, for example, take this one. And then we get a better view of what is taking so much time. It's, as you can see, it's because there are a lot of things going to the database. Those are actually, you can see that that's the URL of the RDS cluster. And you can see that there are some failures, and there's a stack trace you can see as well. Because this is a lot, it's sometimes nice to see a node graph. We can see there went one request from share the web client from your browser, or my browser in this case, to the share backend. And then one request went to ACS, but like 1,309 requests went to the database. So that's why this request took so long, because Alfresco is doing a lot of database calls for this one. There are also buttons to go to the X-ray console. I already opened some. As you know, X-ray has its own web interface inside AWS, and you can still go to that one, and they will give you a little bit more detail. Like here, you can see the actual queries that are running. You can open them up. It's currently not responding that, but you can see a bit more details on the queries. And that concludes this part of the presentation, and I think the entire presentation. So we have a few minutes left for questions, so feel free to ask them.
There aren't that many questions in the Q&A, I see. There was just Angel thanking us for the presentation, but having to drop off. If there are questions, please raise them. But I would like to take the opportunity, first of all, to thank the audience for its patience and the speakers for animating the audience, because I followed the number of people in the webinar and actually nobody dropped off. It was a pretty, I think, technical webinar in the second half of the Xenet part, but it's also, this is real, how it has been realized. And we heard more about the why and the architecture in the first part by Miles and Mark. And Joost and Thijs showing off, I think, great features that bring us all together on the way to operational excellence with observability, automation, build and deploys. There is a question. Yeah, okay. Rodrigo, thank you very much. It is our pleasure. Most importantly, of course, we will share the recording and the slides with all the entities, even more people, because more people registered, but as it goes with webinars, not always everybody can make it, but lovely to have the attendance and the presentations, and I think our contact data, etc., are on, so you can always find us. I don't think there are more questions, so I think it's a right moment to conclude. And thank you all for your attendance. Thank you very much, speakers. Thank you, Mark. Thank you, Miles. Thank you, Joost. Thank you, Thijs, for having entertained us and enlightened us.
Thank
See
you
you
for
on
the
our
invite.
next webinar.